Okay, in matrix addition and subtraction, there's a couple things that you need to know. Just like everywhere else in addition and subtraction, you can only add like terms. So remember, you can only add x's, so like 3x plus 4x is equal to 7x, but 3x plus 4y, you can't combine those two, so this is as simplified as it gets. Well, in matrix addition and subtraction, each matrix must be the same size, and we're going to name them, identify them. You identify a matrix by the number of rows. You put the X for the word by, the number of columns, and I actually did this incorrectly. There's 1, 2, 3, 4 rows, not 3. 1, 2, 3, 4. And there's only one column. So each of these, each matrix is a 4 by 1. Okay, so if each matrix is identical, you can go ahead and add and subtract. And here's the key thing to remember. It's location, location, location. So the top item, subtract the top item, subtract the top item. So -6, subtract 0, subtract 4. Well, we don't have to worry about the 0, so -6, subtract 4. Remember, subtracting a positive is the same thing as adding a negative. So when you add -6 to -4, you get -10. So in the answer matrix, which is also going to be a 4 by 1, and in the top answer, you already solved, you have -10. So here's an example again. So notice I've highlighted the third spot, and I just brought them down. -2 I bring down. I highlighted the operator, which is the subtract sign, and I brought it down. The 5 brought down, the subtract sign again, and then the -3 in the last. Now, the best thing to do is simplify first before you solve. So this is what I did. -2, subtract a positive is the same as adding a negative. -2 plus -5 is -7. Subtract a negative. When you remove a negative, things are positive. A double negative is the same thing as adding a positive. And so -7 plus 3 is -4. And notice it's in the same location. This is the first, second, third, fourth, and this is in the third location, like this one, and this one. You keep locations the same. And 4 by 1, 4 by 1, 4 by 1. Always label, identify each matrix. Okay, now we're going to go on to scalar multiplication. Scalar multiplication is when a matrix is just scaled. Anytime you multiply or divide something, you're changing the scale or the size of it. So look, when a number is on the outside of the matrix, and actually it usually would look like this, kind of in the middle, it's just going to act as a distributive property. You're going to multiply that 3 by each number inside. So 3 times 1 is 3. Make sure you put in the correct location. 3 times 0, it's the middle location, so we put a 0. 3 times -2 is in the bottom location, so we go ahead and put -6. So that's all there is to it, and notice I identified the answer matrix. Now, we put this whole thing in parentheses and put a number on the outside of that, we first could solve the inside one, and the inside one is what we have here. We have 3, 0, -6. That was 3 times this matrix. And then 5 times that result And this is a 3 by 1. The answer will be a 3 by 1. 5 times 3 is 15. 5 times 0 is 0. 5 times negative 6 is negative 30. Or, what you could do, and this only works with scalar multiplication, that's it. You could go ahead and multiply 5 times 3 first. That becomes 15. 15 times 1 is 15. 15 times 0 is 0. 15 times negative 2 is negative 30. And oh look, these two agree with each other. So you could do it either way. You can do this part, the inside first, which is order of ops. But I'm going to show you when to follow order of ops exactly and when you can kind of take a shortcut. All right, that's it.